an area of trigonometry, and it's the area of a triangle, which is one of the easier formulas for finding something in trigonometry. Now, you can actually use this for right angle triangles, but you can also use it for non-right angle triangles. So it works both on a triangle which is right angled, like this one, where you've got a right angle, or you can use it on a triangle that's not right angled, like this triangle. Okay, usually when you've got a right angle triangle, the area is still the easiest to work out, is a half times the base times the height. Okay, so, which is our old one from area and volume, because usually in a right angle triangle you've worked this out and you've worked this out, or it's easier to do that, to use this formula of a half base times height than it is to use this one that we're going to do today. But you could still use your formula for a right angle triangle or a non-right angle triangle. So the main thing when you come to use it for a non-right angle triangle or for a right angle triangle, the main thing again is the labeling. And we found this in trig already, that it's so important how you label your triangles. Now remember, with a right angle triangle, with a rat, what was important was if we had an angle, say x, we had the opposite, the hypotenuse, which was opposite the right angle, and we had the adjacent, and that's how we labeled our triangle when it was a rat. For non-right angle triangles, our labeling changes, and this is kind of the step up from junior cert. With a non-right angle triangle, or a non-rat, or a mouse, or whatever you like to call it, okay, we have a different way of labeling, and the different way of labeling that we have is that angles are called capital letters A, B, and C, and sides are called small letters A, B, and C, and these go together. So there's always a connection between the capital letter angle and the small letter side. So let me just draw a bigger version of this triangle, and we'll fill it in. So say we had this triangle, we might have that this is angle A, this is angle B, and this is angle C. So all our angles, as you can see, are capital letters. And, you know, they'll make that clear in the diagram. If they don't have it clear in a diagram, you can draw a diagram and fill in the information yourself. So again, diagrams, we'll just put a little note that there to remind us, diagrams are always useful and always helpful. Now, if I say that this is angle A, the side that goes with angle A is side A, and it's the one that's directly across the triangle from angle A. The side that goes with angle B is directly across the triangle from angle B, and it's called side B. And the angle C, the side that goes with it obviously, is the one across the triangle, and it's called side C. So angle A is here, side A is directly opposite it. Angle B is here, side B is directly opposite it. And angle C is here, and side C is directly opposite. So this is an angle, this is an angle, and this is an angle. This is a side, this is a side, and this is a side. Any questions on that? So the formulas we're going to use for non-right angle triangles, non-rats, all rely on these letters A, B, and C. So anytime you see a capital letter A, you know it's an angle A. A capital B means angle B, and a capital C means angle C. A small a means side A, a small b means side B, and a small c means side C. Small letters mean side, capital letters mean angles. When you come to do the area of a triangle, which is our first formula using this new notation, the area of a triangle, is equal to a half a b sine c. So let's think about what does that mean. And this is in your tables, of course, so you don't have to learn it. So what does that mean? It means that the area of a given triangle is a half. Well, that sounds familiar because we had a half base times height. So that half isn't a surprise. This A means side A. So it's a half the length of side A times the length of side B times the sine of the angle C. So it's a half the length of side A times the length of side B times the sine of the angle C. How does that work? Well, let's draw an example here. Okay, say this is 120 degrees and say this was 23 centimeters and say actually that's gonna, let me just work this out here. Let's say that's 23 centimeters. Let's say that is 20 centimeters and let's say that is 12 centimeters. Now, the first thing we would do when we come to use this formula or any of the formulas is that we would have to label our triangle, just like we've always done with SOHCAHTOA and right angle triangles. So this angle here would be angle A, which would mean this side here would be side A. This side here might be side B, and this side here might be side C. So the first thing we have to do is to label our triangle. Now, if you notice, I've actually dug myself into a bit of difficulty here because there's no side A in this formula, and there's no side C in this formula because the sides are A and B, and the angle is C. So I might actually have to redraw this triangle, and I might have to say, well, actually, this is the angle that I'm given, and for my formula, I need that to be C. So my angle I need is angle C. This is side C. I better call this A, and I better call this B. So it's really important that when we label our triangles, we do it in a way that helps us to use the formula we're using. Now we'll come back in a moment to see how we could use our original labeling. But for now, here's our triangle. This is our angle C, opposite side is side C. This is our side B, this is our side A, this is our side B. What was our formula? It was a half times A times B times sine C. So filling that in, I have a half times 20 times 12 times sine 120. A half times the length of side A, which was 20, times the length of side B, which was 12, times the sine of the angle there, C, which was 120. You may notice that actually the formula effectively works out, and this is how I'll talk about it when we use it, over the next while in the exercise. It's a half of a side by the sine of the angle in between. So in a way, that makes the labeling something that we can mess about with to get our correct formula use. A half of a side by the sine of the angle in between. So what you end up with is you end up with the key parts of the triangle that you need, or a side by the sine of the angle in between. And as long as you have that kind of chain of information, side, angle, side, you can use this formula. A side, an angle in between, and a side. So here we have a side, an angle in between, and the other side on the other side of that angle. So it's a half by 20 by 12 by sine 120. Plug that into your calculator. A half by, what did we say, 20 by 12 by sine 120. And that tells me that the area of that triangle, very unhelpfully on my calculator, is 60√3. That means very little to me. So let's press the SD button. The area of that triangle is 103.9 units squared. So how would I how would I have used this to help me with my labeling that I started with originally? Well, if it's a half of a side by an angle in between, then it would be a half of a side, which is 20, by a side, which is 12, by the sine of the angle in between, which is sine 120. It's the same thing. Side by the sine of the angle in between, which would give me 103.9 units squared. Okay, let me do one more example and then I'll take any questions. So a nice straightforward example. Here's our triangle. We're told that this side is this angle is 37. We're told that this side is 8 and this side is 10. In this case, we're told they're centimeters. First thing we do is to write down our formula. Area triangle is a half by A by B by sine C. Or if we want a half by the side, by the sine of the angle in between. Okay, so looking at this, let's label them. This is going to be A. This is going to be a side because it's a small letter, so it's a side B, and this is going to be the angle in between, which is C. So my area of this triangle is a half by 8 by 10 by sine 37. I just plug that into my calculator. A half by 8 by 10 by sine 37 equals 24.07 centimeters squared. To the nearest whole number would be 24 centimeters squared. Okay.